Look at the smartphone in your hand. Look at the smartwatch on your wrist, the drone hovering in the sky, or the router silently powering your entire digital life. Have you ever wondered how, in less than a single lifetime, one specific corner of the globe managed to build almost all of it? We often assume the modern technological revolution was born in the sleek, glass-walled campuses of Silicon Valley. But the truth is much darker, more calculated, and far more fascinating. The actual beating heart of global technology doesn't just design the future, it physically assembles it, piece by tiny piece, at a scale the world has never seen before. Imagine a place where a hardware prototype that would take months to build in the West can be conceptualized, engineered, and manufactured in a single afternoon. This is not science fiction. This is the reality of a global monopoly on manufacturing. But how did a desperately poor, isolated nation systematically maneuver itself to become the indispensable tech factory of the planet? The answer begins in a place that, just 4 decades ago, barely existed on a map. Rewind to the year 1979. The world was divided by the Cold War, and China was largely sealed off from the global economy. On the southern coast of China, just across the border from the glittering, wealthy British colony of Hong Kong, sat a modest, marshy area known as Bao'an County. It was a sleepy fishing village and agricultural zone, home to about 30,000 people. The residents lived a quiet, rural life, entirely disconnected from the technological leaps happening in America or Japan. Yet, within a blink of historical time, this muddy terrain would mutate into a hyper-industrialized, neon-drenched megacity of nearly 20 million people. How exactly does a fishing village transform into the Silicon Valley of hardware? The catalyst was a singular, unprecedented political gamble. Chinese leader Deng Xiaoping pointed to this exact spot on the map and designated it as China's very first special economic zone. The city was renamed Shenzhen. The rules here would be drastically different from the rest of the country. Foreign investment would be welcomed. Private enterprise could exist. Capitalist practices, strictly forbidden elsewhere in the nation, would be tested here behind closed doors. It was an audacious experiment, and the world slowly took notice. Initially, the companies that arrived weren't building advanced robotics or smartphones. They were manufacturing cheap plastic toys, textiles, and simple electronics. They came for one undeniable reason: heavily discounted labor. Millions of young workers migrated from impoverished rural provinces to Shenzhen, willing to work grueling hours for a fraction of what an American or European worker would demand. But while foreign executives thought they were simply exploiting a massive, cheap workforce, Shenzhen was quietly doing something else. It was learning. A unique, underground culture began to brew in the back alleys and small workshops of this new city. It was called Shanzai. Originally a term for bandit strongholds in the mountains, Shanzai came to mean the illicit copying and counterfeiting of branded electronics. Local tinkerers would take apart Nokia phones, Sony radios, and Nintendo consoles. They would reverse engineer them, figure out how the circuits communicated, and build cheaper, modified versions. To the West, this was outright intellectual property theft, a nuisance to be eradicated. But from a purely evolutionary standpoint, it was a massive, decentralized training program. A whole generation of Chinese engineers was learning how the world's most complex consumer electronics worked from the inside out. They were learning how to source raw parts, how to redesign circuit boards on the fly to fit cheaper casings, and most importantly, how to do it with terrifying speed. As the year 2001 arrived, a seismic shift occurred. China officially joined the World Trade Organization, the floodgates opened. The world's biggest tech giants rushed in, eager to maximize their profit margins. But what they found in Shenzhen and the surrounding Pearl River Delta was no longer just a pool of cheap labor. They found an invincible ecosystem. There is a deeply misunderstood concept about why the world's electronics are made in China today. The popular belief is that it is simply cheaper. That is a myth that has long expired. Today, wages in China's tech hubs have risen significantly, far surpassing those in countries like Vietnam, India, or Mexico. Yet, the tech giants cannot leave. The answer lies in the uncompromising efficiency of the Chinese supply chain. Imagine you are building a new prototype for a smartphone. You need tiny specialized screws, custom-cut Gorilla Glass, specific microchips, microscopic copper wiring, and highly customized lithium-ion batteries. If you are an engineer in the United States or Europe, sourcing these components from different specialized suppliers could take weeks of shipping, customs delays, and logistical nightmares. In Shenzhen, all of these factories are within a 50-mile radius. You can place an order in the morning, and the physical components will be driven to your assembly plant by the afternoon. Nowhere is this physical reality more visible than in Huaqiang Bay, the largest electronics market on Earth, situated right in the heart of Shenzhen. It is a sprawling, multi-block maze of towering buildings, packed with tens of thousands of tiny booths. You can walk into Huaqiang Bay empty-handed and walk out with every single microscopic component needed to build a functioning smartphone from scratch. It is a hardware engineer's paradise, a physical manifestation of an unparalleled, hyper-dense supply chain. Consider a famous, verified incident involving Apple just weeks before the launch of the original iPhone in 2007. Steve Jobs famously demanded a last-minute design change, requiring the phone's screen to be switched from plastic to scratch-resistant glass. The deadline was impossibly tight. In America, finding a factory to cut the glass, sourcing the raw material, and hiring the skilled workers would have taken months, pushing back the launch and costing billions. Apple turned to a Chinese factory. When the executives arrived, they found that the factory owners had already built a new dormitory on site to house the workers. When the newly cut glass arrived at midnight, engineers immediately woke up 8,000 workers. They were given a quick meal, and within hours, they were manually fitting glass into iPhone frames. They were producing over 10,000 iPhones a day within a week. No other country on Earth could match that speed, scale, and brutal operational efficiency. The supply chain had become a weapon, and China held the trigger. For a long time, the global perception was comfortably fixed, designed in California, assembled in China. China was the hands, but the West remained the brain. Chinese products were widely dismissed as cheap, low-quality imitations. But under the surface, a deliberate, heavily funded, and highly secretive transformation was taking place. The Chinese government and its rising tech billionaires realized that being the world's factory floor was not the endgame. In fact, relying solely on assembly would eventually lead to economic stagnation once wages rose too high. It was merely step one. Step two was owning the technology itself. The shift from imitation to true innovation did not happen by accident. It was codified in a bold state policy known as Made in China 2025. The goal was simple but audacious: transition away from low-end manufacturing and aggressively dominate high-tech industries like aerospace, robotics, and green energy. The Shanzai copycats of the early 2000s began to mature. They had accumulated vast capital. They commanded the world's best supply chain. And now, they had the ambition to invent. Look at the skies above you. Today, if you see a consumer drone filming a movie, a commercial drone inspecting a bridge, or a tactical drone being used on a modern battlefield, there is a staggering probability it was made by one single company, DJI. Founded by a young student in a Shenzhen dorm room in 2006, I didn't copy Western technology. It invented a consumer market that barely existed. Because DJI was physically located in the heart of the world's fastest hardware supply chain, they could iterate and improve their prototypes at a speed Western competitors couldn't even comprehend. By the time an American drone startup finished a digital blueprint, DJI had already manufactured, tested, and released 3 new physical models. Today, DJI controls over 70% of the global civilian drone market. They are not a cheap alternative. They are the undeniable pioneer, forcing Western competitors into bankruptcy. Then came the invisible infrastructure of the modern world: telecommunications. For decades, Western companies like Ericsson and Nokia dictated the terms of global communication networks. But a company founded by a former Chinese military engineer, Huawei, slowly began to rewrite the rules. Initially, they survived by selling cheap telecom switches to rural areas. But they aggressively reinvested their profits into research and development, eventually outspending their Western rivals by billions of dollars. By the time the world was ready to transition to 5G technology, a shocking reality became clear. Huawei wasn't just catching up. They were years ahead. They held the most critical patents. Their equipment was demonstrably more advanced, and it was significantly cheaper. The sudden realization that a Chinese company was positioned to build and control the central nervous system of the 21st century's digital economy sent shockwaves through Western intelligence agencies, sparking a geopolitical tech war that rages to this very day. The narrative of China merely being a copier is now dangerously obsolete. We are entering the era of artificial intelligence, green energy, and advanced automation, and the center of gravity is decisively shifting east. Take the electric vehicle revolution. For years, Tesla was the undisputed king, the symbol of electric mobility. But quietly, Chinese companies like BYD began building an empire. BYD didn't start as a car company. They started as a battery manufacturer supplying early cell phones. Their founder famously drank battery fluid in front of investors to prove its safety and reliability. They understood that the future of cars was not the engine, but the battery. They didn't just build cars. They engineered total control over the entire process, from mining the raw lithium to manufacturing the battery cells, right down to the final assembly of the vehicle. Today, Chinese ports are clogged with massive, custom-built cargo ships, specifically designed to export thousands of advanced, highly affordable electric vehicles to Europe, Asia, and beyond. They have cracked the code of making complex, green technology at a scale the legacy automakers of Detroit and Germany are struggling to comprehend. In the realm of artificial intelligence, the competition is even more intense and far less visible. While Western companies capture global headlines with generative AI chatbots, Chinese institutions are quietly filing more AI patents than any other nation on Earth. AI requires 2 things to grow: massive computing power and an ocean of data. With a population of over 1 billion people seamlessly integrated into digital payment and social systems, China possesses a data advantage that is mathematically impossible to replicate in the West. They are deploying AI not just in software, but in the physical world. They are building massive facial recognition networks, highly automated smart cities, and autonomous megaports, where ghost-like robotic cranes unload cargo ships with terrifying precision, without a single human on the dock. This rapid, unprecedented ascent has not gone unanswered. Alarmed by this sudden technological parity, the United States and its allies have enacted sweeping historic export controls. These sanctions specifically target China's access to the world's most advanced microchips and the incredibly complex machines required to make them. The strategic goal is clear: choke off the extreme computing power required to train the next generation of artificial intelligence and advanced military systems. It is a high-stakes, invisible blockade, aiming to sever the absolute cutting edge of science from the world's ultimate manufacturing hub. Yet, the sheer momentum of an ecosystem built over 40 years of relentless labor is incredibly difficult to break. Every sanction, every restriction seems to act not as a deterrent, but as a harsh catalyst. It forces Chinese tech giants to accelerate their own domestic research, pouring hundreds of billions into creating their own semiconductor foundries, determined to close the final loop of total technological independence. The transformation is complete. The muddy fishing villages of Bao'an County are gone, permanently buried under millions of tons of concrete, glass, and fiber optic cables. The era of cheap plastic toys and imitation phones has been systematically replaced by the mass production of quantum computing components, autonomous vehicles, and deep learning servers. The world sent its blueprints to the East to save a few dollars, unknowingly transferring the greatest concentration of manufacturing knowledge in human history. They did not just build our devices, they learned how to build our future. And now, the true architect of the 21st century has awakened, no longer content with just following the instructions, but fully prepared to write the code for the rest of the world.